Hello, this is Paul from Foresight Tech. In this lecture, I'm going to introduce how to find the average value of a function, or what does the average value of a function mean. We have to find the average value using integration. So what is the definition? So let's look at it here. The average value of a function fx between a and b is just the integration divided by the range of the interval b minus a. Later, I'm going to draw a graph. Okay, the graph is here. I'm going to show you understand what that this definition mean. Okay, so first, please follow step by step. So we're going to show here. Okay, if I give you a definition, is this. Okay, what does this number mean? So first look at it. This number should be between the minimal x, the minimal value of f, and the maximal value of f. Using the comparison property. Okay, so we learned before comparison. Okay, because this is a I'll show you here because b a f x dx less than capital M times BA, this comparison, remember this, the lowercase m and b minus a, and then we divided by b minus a, divided by b minus a, divided by b minus a. See, what do we have? Cancel this, cancel this. So we will have this result. The definition of the average value should be between the smallest value and the maximal value. Okay, you will have this, and then do you remember we have a intermediate value theorems from Calculus 1 at the beginning? If f is continuous, the continuous function can take any value between the minimal and the maximal. Remember that. Therefore, we have these results. Exists a number c between a b such that fc equals this value. Okay, because this value is between the minimal and the maximal. Okay. In this case, and then we will plug fc to there. See, what do we have? So now fc equals f value, so equals this definition, right? And then that times b minus a both sides. See, what do we get? We will exactly get this result. Exists the number c, so fc times ba equals this integration. Okay, and this is famous. This result is famous, called the mean value theory. It's not for continuous function derivatives, but here is for integrals. Okay, see, and this integral can describe by a value. This we call the average height. Okay, or the average value times b minus a. B minus a is the interval. Okay. And the exact way to understand this formula, the mean value theorems for integrals, this graph. Okay, so everyone, now let's look at this graph. If I draw a graph f, a, b is this, the minimal, the maximal, and this the mean value tells us what? fc, where is fc? Okay, so first, the average value is between the lowercase m and the maximal. If I say it's there, means this height is fc. See, you draw horizontal line. Can we find a c? Yes, definitely. We definitely can find a c. Okay, because this is a value between, and the f is continuous. You definitely can find the intersection, and then do projection. You definitely can find at least one c, right? Okay, and then now we can understand fc is the height of this rectangle. B minus a is the width of this rectangle. The height times the width is the area. So this is the area of the rectangle. What that? That's the area under the curve, right? So from this is the mean value, exactly tells us the area under the curve can equal to a rectangle. What is the height of the rectangle? The height of the rectangle is the average value. We call it the average height, right? Average height is this height. Why? Because the two areas are equal to each other. How do you find this average height? Now we already have a definition. use the integral divided by BA. Okay, keep in mind that this is the best, this is the most important formula. Now I'm going to show you two examples. Is the average value of the function is all the function integral, right? This is the area divided by the width, so B minus divided by the range of the interval. And then look at these questions. Okay, so now find the average value. So what definition we have, right? Okay, the interval we gave, the function we gave, the average value now is just use the definition. So how to say f average value is defined in this now is what? Is 1 divided by b minus a, right? If I use the formula b minus a integral from a b f x dx. I just showed you how to understand this. Okay, the area divided by width is the height, average height of the function, average height. Then plug everything in. 1 over b minus a, 2 minus negative 1 is 3. Integration negative 1 to 2. Fx 3x squared plus 8x. Everyone knows how to do calculation, right? This is the fundamental. We have a basic formula because this is a power function, so I directly going to use the fundamental. And that derivative is this, and I'm going to find the end derivative. 3x squared is x raised to the third power, and this is a plus 4x squared, right? Okay, this is the end derivative between negative 1 and 2, and then plug everything in. So the first, so we're going to see 2 plug-in is 2 third plus 4 times 2 is 2, and then minus 1, which is negative 1 raised to the third, then minus 4 times negative 1 raised to the second. So it does everything. Use your calculator to calculation. What do we get? We get a 7. Okay, calculation is not the most important. The most important is there, the formula. This is the important. One more. Okay, look at these questions. And before I look at this, here the question. Okay, and if we have a linear density in a rod, is a meter long, and the density function is here. What is x? X is measured in meters from one end of the rod. So now find the average density. I mean the density function changes for a rod. See, here is the big density, there's a smaller density. How to find the average density functions? So you can imagine what is the average density. Okay, average density is the average value of the density function. What is the density function? Is there average value of the density function is what? We know how to do, right? Or I draw a graph here, show you. If this is a rod, okay, from the left I equal to 0, so go to the right is 8. I mean do what? You definitely do this, right? Okay, this is the x-axis. Okay, this is a 0. If you draw a vertical line is a y-axis, we don't need it. This is the x-axis. Now we look at this. X is what? X is the distance between 0 to this point, the distance. And the density function, I mean the density at this time point, this point is this function. So how to find it? The average density, average of this function. Do you know what is the average value of this function? We just have, right? And how to do is use this. Use the value. So now we need to see the average density. Now should it be what? Should it be f for the average? F average is this integration. I have to put. So here I missed a little. Is 1 over what? 1 over, I should the formula first, b minus a, right? And here's from a to b, and then f x dx. What is fa? I plug everything. 1 over And what is so can we see what is b? Okay, b is 8, and what is a is 0, so it's 1 a, right? And then the integration is from 0 to a, because x is go from 0 to a, 0 to a. F(x) is what is this function, so up here is 12 over square root of x plus 1 dx. Okay, this is the setting up. If you go to this step now, almost get everything. One more understand, everyone look at this. The density function to integration is what? Is the mass. Everyone, the mass or the weight, the total weight, and then divided by the length is the average density, right? The total weight, how many pounds, divided by the longer, the length, which is the average density. You also can understand, right? Or we use this definition, we also can go to this. Now, what we need is just do calculation. So do calculation, I think you know how to do, right? This looks complicated. We need to do substitution. It's better directly substitute this. Okay, I do substitute u equals x plus 1. Okay, and then what do we get? Dx should be equals du, right? And then the limits. So I put the limits when x equals 0. So u equals 1. Good. When x equals 8, we can find u equals 9. See, that's all we need. This is the substitution. And then we use this substitution, plug in, so we can find is what? Is 1/8 integration 1 to 9, 1 to 9, and then is 12 over square root of u, and then du. Okay, this is the power function, so all we need to do is change it to the power. Sorry. This is 12. 12 put here. Of course, you can simplify this, right? And then it's the integration from 1 to 9. This power is u negative half power, and then du. Okay, so now is what? This is 12 over a. What this? So I'm going to simplify. So this should be plus 1. U raised to the half divided by 1/2, which means times 2. So can we find this times 2, right? So we will have this. We will have 2 times 2. Okay, so we have to times 2 u 1/2. Okay, if you like, you can put this to 1 to 9, do calculation. And after the calculations, so what I get. So this is, of course, this is 3, and the plug in is this 3 times the square root of 9. So this means square root. 1 is 1, and then minus this plug in is 1 minus 3, and then you can simplify. This is 2. 2 times 3, 6. 6 minus 3 is 3. No, this is 3. 3 times 3 is 9. 9 minus 3 is not 3, sorry, is 6. That's the answer. Okay, thank you.